Yep, now it's time for another bracket.
Garage time.
This one's gonna be kind of similar to the one Rennline offers. Also Sierra Madre has one. I'm gonna do a little bit of both, and I'll tell you why it's gonna be different. So I'm gonna run aluminum bars between the struts, and I also wanna run a diagonal bar down to this corner. Now the diagonal bar for the off-the-shelf brackets doesn't have a place to tie it in. So a lot of people tie it into the sheet metal. So rather than drill another hole in the car, I would rather make a unique bracket on the passenger side. Plus, you know, I like to save money. Those things are about 180 bucks. So I'm just gonna do a one-dimensional profile on this blue paper, and I'm gonna transfer it into a three-dimensional shape with sheet metal. A little change of venue. I'm here inside the house now, and I'm at my laptop. I just want to show you how I got that paper template using my computer. Okay, this is an engineering software. It's called SolidWorks, and what I've done is I've taken this template that I've scribbled on and cut out on the car, and I've scanned it and I've imported it into this software. So you can see this shape here. If I zoom in, you can see these are my kind of squiggly lines, and then I've traced it with true arcs to sort of even out all the undularities of my cutting scissor method. So this is fully outlined with these black lines. And then this is a three-dimensional tool, so I can turn this into 3 dimensions pretty easily. This is a sheet metal module, so it allows me to create it in 3 dimensions and then allows me to flatten it. So there it is, flattened. I was able to electronically put these holes at equal distances, get these holes here centered around that arc. It just makes it easier. And then I'm able to print this in 1-to-1 scale. So here's the page that I print, and it has a few, dimensions on it just for my own use. Not fully dimensioned, but good enough for me. So what I do is I print this out, I cut it out with scissors once again. This time the lines are a little bit more accurate. And then I trace that onto the metal, and I did the plasma cutter. Everything else was done from there. So this is a little bit of a look into kind of my engineering world. Pretty simple, takes me just a few minutes and really gives a better outcome. I got this piece cut out and it's looking really good. I was unable to bend it the full 90 degrees because of the limitations of the brake, So I'm going to have to hammer the rest of this, but now that the flange is started, it's definitely helpful. I'll probably end up using the vise and the table just to kind of hammer this back to a 90-degree bend. These are supposed to be, you know, straight up and down. And I put in the holes for more speed holes. So to match the back, I want to put more holes in. So on this one, it's a pretty compact area and it's a different size than in the rear. So I'm going to make some steel dies that will do the dimples here. Okay, what I thought was going to be a simple job of making some dimple dies proved to be not so simple, just like everything else. I was able to get this one done. This is the male portion of the dimple die. This was pretty straightforward. However, I ran into some trouble on the female side. This is the female side, and this internal chamfer was a little more difficult than I expected. The tooling available is limited. It's a community-based workshop, and the tooling is free. It's available, but you don't always have what you need. So all the cutters were sort of for external cutting, faces, open faces. So the tool holder itself was actually running into the small hole here. So what I really needed was a boring bar, and the boring bars they had were too large, too big for this a 3/8 diameter hole. So I'm going to have to go back into my own shop and figure something out. I can rough this out with almost anything. Just need to create kind of a conical hole. Doesn't need to be precise. It just needs to be able to you know, drive the sheet metal down inside there. So that's where I'm at. I will be back at home in a few minutes. Yes, this is rain on the window, by the way. It does actually rain in Southern California. First time in, like, I don't know, 3 months. Okay, here's where I'm at with this female portion of the dimple die. So I've taken the die and I've kind of pushed it onto this 3/8 inch shaft. So I hope it'll stay on here. It's kind of a friction fit. Feels okay. So I'm going to now grind the chamfered shape into this part. And just gonna spin it and then use my my grinder on the inside. Now, I do have some countersink tools that I think are 45 degrees or close to 45 degrees. But I'm not going to destroy them on this material. This is stainless steel. It's actually very difficult to machine. So the only thing I feel comfortable with the tools that I have is, because I don't have the carbide tools, I'm just going to use the grinding wheel. This is from this shaft is from a jet ski drive shaft. So I know it's stainless steel. It is a machinable stainless steel because that's how the shaft was made. Here's the formed piece, and the impressions came out really nice. It's very crisp, especially on the backside, which you won't be able to see for this part, but it's a pretty deep dimple. I did 45-degree chamfers, so it goes down pretty deep. The hole does open up a little bit. It's bigger than 3/8 now after the metal, you know, stretches. But I'm pretty happy with this. You might have been cringing or chuckling at my machinist methods, but you know, at the end of the day, I was trying to make a sheet metal part, and it works. Okay, all is going pretty well with these parts. I did make 2 of the identical parts. The passenger side is going to be modified on the lower section. So I mentioned that these are the strut tower braces, and there's a bar that goes between them. But there's also a diagonal bar that goes from here down to here. So I'm going to be adding some additional brackets onto here. I couldn't form them into the part because this metal's already formed down, and I want to form it up as well. So I'm going to have to add some metal on that. So I'm going to be working on that too. But I wanted to make 2 at the same time because it's just quicker. Now I'm ready to put the dimples in. And the dimple die here on the top is working like it should. I drilled the holes and this is going in. Everything's good. Now, this piece is too big to go between here like this. So it's just a little too big. Now, I remembered that this is 1 inch on the internal, and I was supposed to, at the workshop, I was supposed to mill the edges flat. So I'm not able to do that since I'm at home now. I'm going to just put this in my vise and just grind it off with a big grinder. So this will go down inside the channel, and then I can squeeze the dimples in. All right, there it is, just sort of taped in place. The side here is going to need a little bit of trimming just to make it fit more flush prior to welding. I'm not going to weld the entire length of this. I'm just going to stitch weld it a few different areas, but it's roughly in position. I'd love to tack it in right now, but I'm not going to do that until I put the strut back in and lower the car back down on its 4 wheels. I don't want any sort of rotation in the chassis or twist in the chassis to be locked in place by welding it this far. I don't think it's going to distort too much based on the way the car's supported, but I want to be safe. And I also want to take my time and strip some paint off and actually do some seam welding. For instance, right here is a seam which could be welded. There's a lot of seams here in the front along these gas tank support panels that I'm going to try to improve by welding. All right, I'm really happy with the way this piece turned out. The dimples I think look great. Didn't distort the part too much. I just put these holes in here. These holes are a little small. I don't know what kind of hardware I'm going to be putting in here yet, so I'd rather just have some pilot holes there. I can always punch them out bigger later once it's even welded in the car. But this is coming together pretty nicely. Who knows if these changes are actually going to be noticeable in the way the car drives. I have a feeling that just the bracket itself does increase the stiffness of the shock tower. And then when you tie the 2 together with a strut bar going across, I really do believe it's beneficial. So thanks again for watching, and we will see you next week. Take care.